we are going to continue our topic, that is hydrocarbon and its compounds, and this is part 6. And in this lecture we are going to study about 3 topics: functional group, alkyl radical, homologous series. And first one is functional group. So let's begin from functional group. First I am going to introduce you functional group, means its definition. Before that I am going to tell it orally, okay? And functional group is a atom or group of atoms that determine chemical properties of hydrocarbon. Whether the given hydrocarbon is hydroxyl, whether it lies in aldehyde, ether, like that. Suppose if we take example as a compound, means alcohol as a compound, then it is hydroxyl, okay? And when we study further we'll understand very easily, okay? So don't rush, be slowly, read slowly, okay? Functional group functional group excuse me, functional group is an atom or group of atoms, okay, that determine chemical properties, means that determine chemical properties of hydrocarbons. Functional group is an atom or group of atoms that determine chemical properties of hydrocarbons. Here, hydrocarbons, okay? And similarly, its examples are hydroxyl, okay? Hydroxyl, like that. Ether, aldehyde, similarly, like that. These are some examples of functional group. And here we discuss some, means its structure, okay? First one, we are going to take hydroxyl as first example, means structure of hydroxyl, means that is OH, means its structure is OH, simple single bond OH. This is single bond, okay? Here single bond OH. This is its structure. Similarly, we take aldehyde, okay? Structure of aldehyde means here we direct write aldehyde, and its symbol is CHO, and its structure will be like that. C means O and H, like that. This is its structure and this is its symbol. Remember, okay? These all are symbol, and this is structure, and this is structure, this is symbol. And here I am going to give you a chart which help you to know many functional group, okay? And before that, here see its compound. Its compound is alcohol. The compound of aldehyde is itself aldehyde. Okay, aldehyde. In any hydrocarbon, OH is joined over there, then we know such compound as alcohol, means such compound is alcohol. And if CHO is joined with that, then we understand that it is aldehyde. Means before that we write here many things, means such as formaldehyde, like that. Okay, and here I am going to draw it, and I will give you chart. This is chart that will help you. And here are some functional group, means in first number hydroxyl, and its symbol is OH, means its symbol is OH and its structure is OH. And organic compounds, OH means alcohol. If any compound has OH, then we understand that such compound is alcohol. Okay, and in second number carboxylic acid. In second number, what is carboxylic acid? Its symbol is COOH, single bond COOH, and its structure is C double bond O single bond OH. This one is OH. Okay, OH. Here single bond C, again single bond OH, then double bond O. Okay, oxygen. O means oxygen. And if any compound contains this, then such compound is acid. Okay, and in third number ether, and its symbol is single bond OH single bond O, means single bond O and single bond. Okay, and its structure is like this. This is single bond, and in between that O is there. Okay, oxygen. And if any compounds contain this, then we understand that such compound is ether. Okay, ether. Aldehyde. Fourth one is aldehyde, and its symbol is CHO. And similarly, its structure is C double bond O single bond H. Okay, C double bond O single bond H. And here aldehyde. And if this is present in the any molecular formula of any compound, then we understand that such compound is aldehyde, but compound should be organic. Okay, and in fifth number, that is keto is there. Keto. Okay, and its symbol is CO. Similarly, its structure is C double bond O, and in this side and this side there is single bond. And if it is present in the compound, then we understand that such compound is ketone. Such compound will be ketone. Okay, and similarly last one amino, means amino, and its formula is NH2, not NH3, NH2. Okay, and its structure will be, and its structure is like that, means single bond and single bond H and H, like that, N H and H. This one, these are also single bond. Okay, like that. And here we understood about functional group. So, and your work is to remember this, because this is important. Okay, and our next topic is alkyl radical. Okay, so let's understand about alkyl radical. Alkyl radical, yes, radical. alkyl radical means, before understanding this alkyl radical, you should know about radical. Do you know radical? If you know, then pause the video and define it. Okay, radical. Here, radical means is an atom or group of atoms that take part in chemical reaction. In earlier classes, in junior classes, we have studied about radical. Means atom or group of atoms that take part in chemical reaction. So let's move ahead and come to our topic, that is alkyl radical. Alkyl and radical. Alkyl radical means what? These are radicals or compounds which are formed by removing one hydrogen from alkane. Okay, suppose if we take alkane example of alkane means example of alkane. Okay, example of alkane, then we know CH4. Okay, CH4. Similarly, C2H6 and many others. Let's draw its chart. Means it's not chart, structural formula. Then we get C hydrogen and hydrogen. This one is methane. We know methane. Okay, methane. And if we remove one hydrogen, then what it becomes? It becomes, if we remove this hydrogen, then it becomes alkyl. Means it becomes the example of alkyl. Means that is, instead of A and E, we write here methyl. Okay, methyl we write. Yes, methyl. Okay, and you should understand about this, because this will help you to understand many other alkyl. Methyl. Okay, methyl. Here E should not be, and here duster, I use duster. Here also E should not be. Okay, so this will be. So let me go to our next example. Structural formula of C2H6. So 2C means C2. Yeah, 2 carbon is there, and 6 hydrogen. Then hydrogen. If we remove a hydrogen from alkane, then that will be our alkyl. Okay, let's remove this. Let's remove this hydrogen. Then our compounds, the form that will be C2H5. Okay, C2H5 radical. Okay, radical, and there it is, radical. So what is this? This is the structural formula of what? Which alkane? Ethane. Okay, ethane. And if one hydrogen is removed, then what it will be? It will be ethyl. Okay, ethyl. And similarly, you can make many like that. You can make structural formula of many alkyl radical. Okay, similarly like that. Okay, alkyl radicals means alkyl, excuse me. As we know, means radical is a group of atoms, so we write here a group of atoms. The group of atoms formed by removing one hydrogen atom from alkane, okay, from alkane. It's called alkyl radical. It's called alkyl radical, okay. And we know what we know. We know the general formula of alkane. Tell me, what is the general formula of alkane? CnH2n plus 2. And if here we write general formula of here alkyl. Yes, alkyl, general formula of alkyl. And according to the definition, the group of atoms formed by removing one hydrogen, removing one hydrogen atom from alkane. Here from what? Alkane. And here if we remove one hydrogen atom from alkane, then it becomes our alkyl radical, okay. So what will be here? CnH2n plus 2. Remove one hydrogen, so I have written -1. And what it gives? It gives CnH2n plus 1. And this is general formula of alkyl radical. Yes, this is general formula for this alkyl radical. Okay, till you up to here. So now we take example, okay. For example, we take C3 at what is 3 into 2, 6 plus 2. C3 at 8. This is methane. And if we remove one hydrogen from this, that is C3 at 2 into 3 minus 1. That is C3 at 6 minus 1. Okay, no, plus 1. Yes, plus 1. Then C3 at 7. This is alkyl. And here this one is alkane. Which alkane? Can you tell me? Yes, propane. Propane it is. And so that it will be how it is. It will be propyl. Propyl, yes. We remove here A and E from alkane, and we add what we add here. Instead of A and E we write yes YL. Yes, YL. And this becomes our alkyl radical. Similarly, like that, our next topic is homologous series. Okay, let me rub this. Wait for a sec. And our next topic is homologous series. What is our next topic? Homologous What is homologous series? Here we have to understand about homologous series. What types of group are called homologous series? What types of series are called homologous series? Homologous series. What is homologous series? Homologous series is a group of organic compounds. Organic compounds. Here organic compounds denotes hydrocarbon. Okay, hydrocarbon. Group of organic compounds which has similar structure and chemical properties, and in which successive compounds, means the compound that comes after another compound, are differ by CH2 with respect to its previous compound. Okay, so let's write here. What is homologous series? The group of organic compounds. Organic compounds. The group of organic compounds having similar. What type of? Similar structure. Similar structure and chemical properties. Chemical properties in which successive compounds are differ by CH2 group. CH2 group. This is called homologous series. The group of organic compounds having similar structure and chemical properties in which successive compounds are differ by CH2 group. Okay. Here we take, suppose example, let's take for alkene. Okay, alkene group. Alkene. Then first one is methane. We know methane. Second one ethane. Third one propane. Third one propane. First one methane, second one ethane, third one propane. Okay, and here we see its molecular formula. Okay, its molecular formula. What is its molecular formula? Its molecular formula is CH4 and its molecular formula C2H6. Its molecular formula C3H8. Just I have dropped there. Okay, so its molecular formula CH4, C2H6, C3H8. Let's minus the molecular formula of methane from ethane. Okay, then we get here C2H6 minus CH4. Okay, this is only for understanding. Okay, here 6 hydrogen, here 4 hydrogen, and then if we minus or subtract here, then how many hydrogen will be? 2 hydrogen, and here 2C, and here only 1C. This is C. Then what will be here? CH2. There its difference is CH2. Let's minus this from this. Okay, and what will you get? C3H8 minus C2H6. What is? Here we get H2, here we get CH. And if we see more, then butane. Okay, butane. What is? C4H10. C4H10. you can do yourself. Okay, subtract this one from this. Subtract now. You'll get CH2, and its difference is also CH2. Here we have done. Okay, here CH2. If you do this, then this and this, then also you will get CH2. Here successive compounds means one after another, one after another. Okay, one after another. Don't take after methane directly propane. Okay, this will be wrong. And if you have to take one after another serially, means first one in second, take 2 in second, 3 number. Don't take in first 1 and then after 3. This will be wrong. If you select randomly, then that will be wrong, because our definition says here, what is here? Homologous series. Here series, okay, organic compounds having similar structure and chemical properties in which successive compounds, successive means one after another, compounds are differ by CH2 group. Here, see, similar structure and chemical properties. Similar structure means its structure, let me rub it. Okay, for methane, structure means its structure is structure for methane. What will be? C H and H. Okay, for H is here, so CH4, and its structure will be C single covalent bond as it is alkane, then 6H H and H. You can see here, compare its structure and its structure. You find similar. Only what happens here, 1 carbon and 2 hydrogen is added over there. Okay, but everything here is same. You can compare it yourself. In the chemical properties means its chemical properties and its chemical properties is almost similar. I am not going to write their similar properties, means their chemical properties. You can search it on Google. Google it, you will find their properties are similar to each other. Okay, so we have discussed in this lecture about functional group, alkyl radical, homologous series, and in next lecture I will give you one chart about homologous series. Okay, for alkane also chart. Okay, just your work is to remember it. So thank you for today.